Hi, welcome to another edition of News at National. I'm Rick Czar. There's a lot of things you have to worry about when designing a power supply for today's generation of FPGAs. The latest FPGAs tend to operate at lower voltages and higher currents than their predecessors. And many of them require multiple power rails, including the FPGA core, the I/O, and additional rails for powering clocks, PLLs, transceivers, and other circuitry. Because of that, your requirements for the power supply are more demanding, and you need to now pay attention to issues such as transient response, power supply sequencing, pre-bias startup, and soft start. If you don't, your design could result in unreliable power-up or other power supply difficulties while the FPGA is in operation. Well, National Semiconductor has just released a new family of full-featured, high-efficiency synchronous buck regulators that will be a tremendous help for these type of power supply designs. The new LM20K family offers a full range of innovative features and options, enabling you, the designer, to fully customize your solution to meet your system needs and reduce your bill of materials. These features include external soft start, precision enable, a power good indication, and tracking that can be used to set the output to accurately track an external supply for sequencing of multiple devices, as well as options for frequency synchronization and out-of-phase clock output. They also offer an adjustable frequency option so you can optimize between your solution size or power efficiency. The power efficiency delivered by these regulators moves them into the new class of PowerWise products from National Semiconductor, National's line of energy-efficient, high-performance analog products. The PowerWise brand highlights National Semiconductor products and subsystem solutions with outstanding performance-to-power ratios, products that are helping you to design systems that deliver the power efficiency you need. The LM201 family of devices has a voltage in range from 2.95 volts to 5.5 volts, and they support loads up to 5 amps. The LM2242 device has a voltage in range from 4.5 volts to 36 volts and supports loads up to 2 amps. When you need to power multiple points of loads, you can use a combination of appropriate devices based upon their features to create a small, efficient, and complete solution with minimal external components or circuitry. One of the tools that are available to designers working with these regulators is an Excel-based component calculator tool. Let's see how that works. There are 9 spreadsheets available. This tool here is the LM20124 design spreadsheet, and it gives you the flexibility of entering in various parameters for your design. The fields that can be changed are shown in blue. So let's go through some of them. Here, the input voltage is 5 volts. The output voltage has been set to 3.3 with a maximum output current of 4 amps. This particular device has a fixed switching frequency at 1 megahertz. You can enter the maximum output voltage ripple. Here it's 1%. And the worst case transient magnitude here, we're going to set that to 3 amps. The spreadsheet calculates a recommended output inductor of 0.94. We'll choose 1 microhenry with an 8 milliohm DC resistance. It also calculates the output capacitor at 106 microfarads and 29 milliohms of series resistance. We're going to set that to 100 microfarads with a 2 milliohm ESR. The estimated transient loop droop is 58.94 millivolts with an estimated output voltage ripple of roughly 3.65 millivolts. As we look down the tool, there's other things that can be calculated here. We can enter the desired crossover frequency. We've selected 50 kilohertz, and the spreadsheet has calculated the compensation components. The first capacitor is 0.85 nanofarads, and the resistor is 35.91 kiloohms. The second capacitor is not required. We then plug in 1 nanofarad for the capacitor and 36 kiloohms for the resistor, giving us a crossover frequency of roughly 50 kilohertz and an expected phase margin of roughly 55 degrees. And that's shown here on the right in this graph. Additionally, thermal performance can be calculated, varying the copper area for the printed circuit board, and the airflow can be adjusted as well. Here the ambient temperature is set for 85 degrees C, and we come in under our 125 degrees C maximum limit at 123.54 degrees C, given roughly 1¼ square inches of copper. Now, what's also available from National is a set of evaluation boards for these regulators. Let me show you how these boards work. In this lab setup, we have a typical FPGA application. Here, there's power supply set with the output to 5 volts. The output is currently off. and we have three of the family here, the LM20, 123, 124, and 125, set up for simultaneous sequencing. The outputs are loaded, and the outputs are also monitored by an oscilloscope. As you can see, when I turn the output on, all the outputs start nicely together. And with truly innovative packaging designs, you can see that the size of these devices are small, just 32 square millimeters, offering high power density in a small package. These regulators are ideal for powering FPGAs, ASICs, and microprocessors, as well as servers, network equipment, navigation systems, LCD TVs, and more. You can find a whole suite of design resources for these solutions in the lower right corner of the newsletter, and much more information online at switcher.national.com. That will wrap it up for this edition of News at National. We'll see you again next time.